Constructing elements with data. The major advantage of using React is its ability to separate data from UI elements. Since React is just JavaScript, we can add JavaScript logic to help us build the React component tree. For example, ingredients can be stored in an array, and we can map that array to the React elements. Let's go back and think about the unordered list in example 4 to 8 for a moment. Example 4 to 8. UL. Ordered list. React.createElementAll, class name. Ingredients. React.createElementLi, null, 1 pound salmon. React.createElementLi, null, 1 cup pine nuts. React.createElementLi, null, 2 cups butter lettuce. React.createElementLi, null, 1 yellow squash. React.createElementLi, null, a half cup olive oil. React.createElementLi, null, 3 cloves of garlic. The data used in this list of ingredients can be easily represented using a JavaScript array. Example 4 to 9. Example 4 to 9. It. M's array. Var items equals 1 pound salmon, 1 cup pine nuts, 2 cups butter lettuce, 1 yellow squash, a half cup olive oil, 3 cloves of garlic. We could construct a virtual DOM around this data using the array.map function, as in example 4 to 10. Example 4 to 10. L. Mapping an array to Li elements. React.createElement. Class name ingredients, items.mapeIngredient equals. React.createElementLi, null, ingredient. This syntax creates a React element for each ingredient in the array. E. String is dis. Played in the list items children as text. The value for each ingredient is displayed as the list item. When running this code, you'll see a console error, as shown in Figure 4 to 2. Figure 4 to 2. Console warning. When we build a list of child elements by iterating through an array, React likes each of those elements to have a key property. Key property is used by React to help it update the DOM efficiently. We will be discussing keys and why we need them in Chapter 5, but for now you can make this warning go away by adding a unique key property to each of the list item elements. Example 4 to 11. We can use the array index for each ingredient as that unique value. Example 4 to 11. Add in a key property. React.createElementAll, class name ingredients, items.mapeIngredient, I equals. React.createElementLi, key I, ingredient. React components. Every user interface is made up of parts. Recipe example well used here has a few recipes, each made up of parts. Figure 4 to 3. Figure 4 to 3. Recipes. In React, we describe each of these parts as a component. Components allow us to reuse the same DOM structure for different recipes or different sets of data. When considering a user interface that you want to build with React, look for opportunities to break down your elements into reusable pieces. For example, the recipes in Figure 4 to 4 each have a title, ingredients list, and instructions. All are part of a larger recipe or app component. We could create a component for each of the highlighted parts, ingredients, instructions, and so on. Figure 4 to 4. Eek. Each component is outlined app, ingredients list, instructions. Think about how scalable this is. If we want to display one recipe, our component structure will support this. If we want to display 10,000 recipes, well, just create new instances of that component. Let's investigate the 3 different ways to create components: create class, S6 classes, and stateless functional components. React.create class. When React was first introduced in 2013, there was only one way to create a compo. Nineth the create class function. New methods of creating components have emerged, but create class is still used widely in React projects. The React team has indicated, however, that create class may be deprecated in the future. Let's consider the list of ingredients that are included in each recipe. As shown in example 4 to 12, we can create a React component using React.create class that returns a single unordered list element that contains a child list item for each ingredient. End in an array. Example 4 to 12. In ingredients list as a React component. Const ingredients list equals React.create class. Display name ingredients list, render. Return React.create element class name. Ingredients, React.create element li, null, 1 pound salmon, React.create element li, null, 1 cup pine nuts, React.create element li, null, 2 cups butter lettuce, React.create element li, null, 1 yellow squash, React.create element li, null, a half cup olive oil, React.create element li, null, 3 cloves of garlic. Const list equals React.create element ingredients list, null, null. React.dom.render. List, document.get element read React container. Components allow us to use data to build a reusable UI. In the render function, we can use the this keyword to refer to the component instance, and properties can be accessed on that instance with this .props. Here, we have created an element using our component and named it ingredients list. Class name equals ingredients. 1 pound salmon. 1 cup pine nuts. 2 cups butter lettuce. 1 yellow squash. A half cup olive oil. 3 cloves of garlic. Data can be passed to React components as properties. We can create a reusable list of ingredients by passing that data to the list as an array. Const ingredients list equals React.create class. Display name ingredients list, render. Return React.create element class name ingredients. This .props.items.map ingredient, I equals. React.create element li, key I, ingredient. Const items equals. 1 pound salmon, 1 cup pine nuts, 2 cups butter lettuce, 1 yellow squash, a half cup olive oil, 3 cloves of garlic. React.dom.render. React.create element ingredients list, items, null, document.get element read React container. Now, let's look at React.dom. The data property items is an array with 6 ingredients. Because we made the syntax using a loop, we were able to add a unique key using the index of the loop. Items equals. Class name equals ingredients. Key equals 0, 1 pound salmon. Key equals 1 cup pine nuts. Key equals 2, 2 cups butter lettuce. Key equals 3, 1 yellow squash. Key equals 4, 1/2 cup olive oil. Key equals 5, 3 cloves of garlic. The components are objects. They can be used to encapsulate code just like classes. We can create a method that renders a single list item and use that to build out the list. Example 4 to 13. Example 4 to 13. With a custom method. Const ingredients list equals react.create class. Display name ingredients list. Render list item ingredient, I. Return react.create element li, key I, ingredient. Render. Return react.create element I, class name ingredients, this.props.items.map this.render list item. This is also the idea of views in MVC languages. Everything that is associated with the UI for ingredients list is encapsulated into one component. Everything we need is right there. Now we can create a React element using our component and pass it to the list of elements as a property. Notice that the element's type is now a string. It's the compo. Named class directly. Component classes as types when rendering HTML or SVG elements, we use strings. When creating elements with components, we use the component class directly. This is why ingredients list is not surrounded in quotation marks. We are passing the class to create element because it is a component. React will create an instance of our component with this class and manage it for us. Using the ingredients list component with this data would render the following unordered list to the DOM. Data React root class equals ingredients. 1 pound salmon. 1 cup pine nuts. 2 cups butter lettuce. 1 yellow squash. A half cup olive oil. 3 cloves of garlic. React.component as discussed in Chapter 2. One of the key features included in the S6 spec is React.component, an abstract class that we can use to build new React components. We can create custom components through inheritance by extending this class with S6 syntax. We can create ingredients list using the same syntax. Example 4 to 14. Example 4 to 14. I. Ingredients list as an S6 class. Class ingredients list extends React.component. Render list item ingredient, I. Return React.create element li, key I, ingredient. Render. Return React.create element I, class name ingredients, this.props.items.map this.render list item. Stateless functional components. Stateless functional components are functions, not objects. Therefore, they do not have a this scope. B. Because they are simple, pure functions, we'll use them as much as possible in our applications. T. Here may come a point where the stateless functional component isn't robust enough and we must fall back to using class or create class. But in general, the more you can use these, the better. Stateless functional components are functions that take in properties and return a DOM element. S. Stateless functional components are a good way to practice the rules of functional programming. Why? Oh, you should strive to make each stateless functional component a pure function. They should take in props and return a DOM element without causing side effects. T. His encourages simplicity and makes the codebase extremely testable. Stateless functional components will keep your application architecture simple, and the React team promises some performance gains by using them. If you need to encapsulate functionality or have this scope, however, you can't use them. In example 4 to 15, we combine the functionality of render_list_item and render into a single function. Example 4 to 15. CR. Eating a stateless functional component. Const ingredients list equals props equals. React.createElemental. Class name ingredients. Props.items.make_ingredient. I equals. React.createElementally. Key I, ingredient. We would render this component with React.dom.render, the exact same way we read. dir components created with create class or S6 class syntax. This is just a function. The function collects data through the props arguments and returns an unordered list for each item that is sent to the props data. One way we can improve this stateless functional component is through destructure. In the properties argument. Example 4 to 16. Using S6 destructuring syntax, we can scope the list property directly to this function, reducing the repetitive dot syntax. Now we'd use the ingredients list the same way we render component classes. Example 4 to 16. D. Structuring the properties argument. Const ingredients list equals items equals. React.createElemental. Class name ingredients. Items.make_ingredient. I equals. React.createElementally. Key I, ingredient. Const with stateless functional components. Each of these stateless functional components uses const instead of var when creating a component. T. His is a common practice but not a requirement. C. Anst declares this function as a constant and prevents us from redefining that variable later. Aside from being slightly cleaner syntax, Facebook has hinted that in the future, less functional components might be faster than create class or S6 class syntax. DOM rendering. Since we are able to pass data to our components as props, we can separate our apply cations data from the logic that is used to create the UI. T. This gives us an isolated set of data that is much easier to work with and manipulate than the document object model. W. When we change any of the values in this isolated dataset, we change the state of our application. Imagine storing all of the data in your application in a single JavaScript object. Very time you made a change to this object, you could send it to a component as props and re-render the UI. T. This means that React.dom.render is going to be doing a lot of heavy lifting. In order for React to work in a reasonable amount of time, React.dom.render has to work smart, and it does. Instead of emptying and reconstructing the entire DOM, React.dom.render leaves the current DOM in place and only applies the minimal amount of changes required to mutate the DOM. Let's say we had an app that displayed the mood of our 5 team members using either a smiley face or a frowny face. We can represent the mood of all 5 individuals in a single JavaScript array. Smile, smile, frown, smile, frown. This array of data may be used to construct a UI that looks something like this. If something breaks and the team has to work all weekend, we can reflect the team's new mood simply by changing the data in this array, producing the results shown in the image that follows. Frown, 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 frown. How many changes do we have to make to the first array to make it look like the second array of all frowns? Smile, smile, frown, smile, frown. Frown, 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 frown. We would need to change the first, second, and fourth values from a smile to a frown. Therefore, we can say that it would take 3 mutations to change the first array of data to match the second. Now consider how we can update the DOM to reflect these changes. One inefficient solution to applying these changes to the UI is to erase the entire DOM and rebuild it, as in example 4 to 17. Example 4 to 17. Start with the current list. Class equals smile, smile. Class equals smile, smile. Class equals frown, frown. Class equals smile, smile. Class equals frown, frown. This involves the following steps. 1. Empty the current data. 2. Begin looping through data and build the first list item. Class equals frown, frown. 3. Build and add the second list item. Class equals frown, frown. Class equals frown, frown. 4. Build and append the third list item. Class equals frown, frown. Class equals frown, frown. Class equals frown, frown. 5. Build and append the fourth list item. Class equals frown, frown. Class equals frown, frown. Class equals frown, frown. Class equals frown, frown. 6. Build and append the fifth list item. Class equals frown, frown. 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 If we change the UI by raising and rebuilding the DOM, we are creating and insert in 5 new DOM elements. Inserting an element into the DOM is one of the most costly DOM API operations. It's slow. In contrast, updating DOM elements that are already in place performs much more quickly than inserting new ones. React DOM.render makes changes by leaving the current DOM in place and simply updating the DOM elements that need to be updated. In our example, there are only 3 mutations, so React DOM.render only needs to update 3 DOM elements. See Figure 4 to 5. Figure 4 to 5. T. ReDOM elements are updated. If new DOM elements need to be inserted, React DOM will insert them, but it tries to keep DOM insertions, the most costly operation, to a minimum. This smart DOM rendering is necessary for React to work in a reasonable amount of time because our application state changes a lot. Very time we change that state, we are going to rely on React DOM.render to efficiently re-render the UI. Factories. So far, the only way we have created elements has been with React.createElement.